Hi all. By now we have learned path analysis and confirmatory factor analysis. It's time to put them together. You will find out that the true power of structural equation modeling is in its ability to estimate a latent factor model by incorporating both measurement and structural considerations. So this week, we are going to learn to synthesize path and CFA measurement models in the latent factor SEM model. In a latent factor SEM model, the CFA is used in the measurement component, in which we define how the latent factors are measured. In a structural component, we specify the predictive relationships among the latent factors. In this process, we will follow the same basic rationales as we have discussed in CFA and path analysis. The dominant practice is to complete a latent factor SEM analysis in 2 steps. In step 1, we validate the measurement model by treating it as a CFA model and assessing the proposed measurement relations. In step 2, we fit the structural model by conducting a path analysis with latent variables. In this process, it's important to remember that the measurement model must be identified in order for the structural component to be identified. As a matter of fact, you need to have a valid measurement model before the structural component of the model can be evaluated. With regard to the model notations in the diagram, there's no surprise. We simply combine the notations we have for CFA and path model together. So the latent factors are presented in oval shapes. Their indicators are measured variables in the rectangles. Each measured variable is related to one latent factor through the factor loading, and also have an error component. We need to estimate the variances of the exogenous factors as well as the disturbances of the endogenous factors. Nonetheless, our primary research interest is in the structural relationships among the latent factors. The unanalyzed component may include the either covariances or correlations between the exogenous factors, and sometimes between the unexplained variances in the measured variables or in the latent factors. Before I use an example to demonstrate the 2-step process of analyzing a latent factor SEM model, there are several issues we need to make clear. First, it's generally assumed that the exogenous factors are uncorrelated with the disturbance of the endogenous factors, because any shared variances between the exogenous and endogenous factors should have been explained by the structural relationships specified in the model. Following the same logic, because the shared variance between a factor and its measured indicator should have explained by the factor loadings, we assume that factors and the measurement errors in the indicators are independent of each other. Second, we need to have the same considerations in the measurement model as in the CFA. Most importantly, each latent variable must have a scale. For exogenous factors, we could accomplish it by either assigning a reference variable or fixing the variance to 1. For endogenous factors, we assign scales by using reference variables. My recommendation, as said in the discussion about CFA, is to use reference variables to assign scales to all latent factors. For disturbances and measurement errors, we usually assign a scale by fixing the residual path coefficient to 1. Finally, we need to remember that the variances of endogenous factors are not considered as model parameters. In the analysis, we estimate the variance of the disturbance for each endogenous variable. Also, the structural model provides the estimate R-square value for each endogenous variable. The R-square value is a portion of the explained variance. The variance of the disturbance is the unexplained variance. The two together will provide the total variance of the endogenous factor. Once you're clear about the concepts we discussed here, you can move on to the next video in which I use example to demonstrate the two-step process of analyzing a latent factor SEM model.